Hello guys, welcome back to the video, and in today's video we are looking for the introduction for the solids. We are starting a new series that is based on the solids, and in this series we're looking all about the solids, their composition, their properties, and the chemical study. And in today's video we have just got a basic introduction of the solids, some of their properties, basic properties. So without wasting time, let's get to it. First of all, you're gonna see some pictures over here. These are solids. Like, I will be explaining the points related to solids with help of these diagrams. Uh, I'm not just defining these all pictures right now. Probably you will understand time by time. I would do this one. You're gonna see that these are different 3D images in front of you, and this is the packing of the solids. And while this one is also the packing of solids in more deeper microscopic way. Now let's start. First of all, solid. So solid is one of the state of matter. There are three different states of matter, and one of them is solids. And what state of matter is solid? Solid is the condensed state of matter. Condensed state of matter. Well, now what does that mean? Like, it has got uh, particular positions. Condensed means stable, most particular, most specific arrangement, positions, attachments, most stable form of matter, we can say that. While this, as we all know that the world is constituted of the atoms, so solid is also made up of atoms, and the atoms arrangement is different in all three states of matter. Like in solids we have got very close arrangement, as seen in this diagram. You will see in this diagram we have got 3D complex arrangement, while in liquids we have got spaces, in gases we have got more spaces. And in solids the atoms have got their mean positions. They cannot move. They maybe can do the vibratory motion, but they cannot move from one place to another. They can just move onto their mean positions. Like you see in the diagrams, every atom is fixed. This is the case in solids, and this property, this arrangement gives them a rigid structure. Like you're gonna see these 3D shapes all have got their own properties. One is having 4 phase, one is having 3 phase, one is having 2 phase. That is because of the atoms arrangement. They are not moving. If they are moving, they may flow like liquids. Okay. Moving for the next point, they resist external pressure applied on them, nearly impossible. Okay, what does that mean? For suppose I just give pressure by over here. I have got a machine, hydraulic pump machine, and just pump it over here. So I just do it over here this side. So this will resist. The solid will resist its shape. It will maintain its shape. Uh, you know, Facing the pressure. To it will fight pressure to the most of its limit to maintain its shape. This is because of the arrangement. When the pressure increases, then the intermolecular forces about the atoms of the solid. So then the shape of the solid will disperse. That means that atoms arrangement is still the same, but the molecules, bigger molecules, get cut it down. We'll be talking about how the solids break in our upcoming videos, and you will get a more clear idea how, like if we got a pressure on liquids, they may spread around, but the solids do not. They have still there got their same arrangement of atoms, but only the large number of atoms break into a small number of atoms. So we'll be talking in the details of how the breakdown of solids take place in our upcoming videos. Okay, moving forward, they have got high density. You will see that they have got proper shapes, they have got proper arrangement, so they have got high density, and their volume is low. The volume is low. What is the reason behind that? Because the density is high, they are more compact, so they have got low volume. While if you talk about liquids, they have got free spaces, so they have got more volume. Okay, so uh, some solids face the melting. While we heat solids, we find that they will melt, otherwise some will do sublimation. There are two types how the liquid converts its state. The one is sublimation, in which the solid directly converts into liquid, directly convert into gaseous state, while in melting the solid will convert into liquid state. Okay. uh, the next point is that they diffuse very slowly. Like it is even said this is impossible to diffuse them. Like uh, here I have got uh, a slit, and here I have got a space in between, and this is a box all around me, and here it is a box, and we have got solid filled inside this. Okay, this is solid. Now remember this will very slowly will drop inside. While if in the case of liquids, if you have got liquids, so in the case of liquids, what would happen is this: if there would be liquids in the box, let me mention that this is solid case, and if we have got, sorry, this is a solid case, and if you talk about liquid case, so here it would be spread all around, and it will flow with a pressure into that container. So this means the diffusion is very slow, or in some cases in which the atoms are greater than the slit space, so there would be no diffusion at all. Okay. Solids expand on heating, but this ability is very little as compared to liquids. Expansion increases their volume. Okay. uh, when we give heat, when we provide the heat, so remember a point over here, that there is a little expansion, because they have got particular, when they have got particular atoms attached, they have got specific network of atoms. When this network bond breaks, so they will expand. A small expansion will take place, but that is even negligible. But if you take about water, so there is a different behavior of water, in which there is uh, a shape difference, a bond arrangement difference, which is noticed, and we will be talking that into our upcoming videos as the anomalous behavior uh, of water. Probably in the liquid chapter we have talked about that, but in solids, remember this, like liquids, in liquid there was expansion of water. In the same case, in solid there is also expansion, but the expansion is very slow. You can see the wires hanging on the electricity poles, they expand and they just became elastic. That is because the heat is provided and their bonds do get weakened. That is the concept. Okay. They have got only the vibration motion of the mean particles. I've told this before as well. Now, remember this: the effect of pressure on solid is expressed in terms of compressibility. This is very important point I'm mentioning over here. The the pressure I have given over here, that is expressed in form of compressibility. Compressibility. Compress means to press. Uh, More formal way to express is compressibility factor. Compressibility factor in chemical terms, and this is expressed in a symbol that is beta. Remember this. This is asked in MCQs. The pressure factor in solids is expressed in which form? This is expressed in compressibility factor form, that is in beta. So we can say the definition of compressibility factor is like the decrease in volume per unit volume when pressure is increased by 1 atm. I'm repeating again. The decrease in volume per unit volume when pressure increased by 1 atm. Now what does that mean? Like if you have got uh, if you decrease the volume per unit volume, like if we have got this much volume, we decrease the volume per unit volume, 1 unit, you decrease this volume. I'm again repeating it: the decrease in volume per unit volume. Like this is per unit volume, this piece is per unit volume, and the shaded part is the decreased part. When 1 atm pressure, one okay, so 1 atm pressure, just 1 atm, 1 atm, just get the concept of this. I'm not going in that much detail. 1 atm pressure is applied, then there is a decrease in the volume per unit volume, then this is called the compressibility factor. And the coefficient of expansion, the little expansion that came, uh, that is uh, expressed in the form of alpha. Remember this again. Increase in volume per unit volume when temperature is increased by 1 degree Celsius. Why we say that compressive factor is the volume decrease when temperature is decreased, uh, temperature is increased by 1 atm. Why did we said that? Because when there would be uh, you know decrease in volume, there must be some sort of heat absorbed. So that is the case. If we talk about the expansion, so there is a heat provided, so we say increase in volume per unit volume when temperature is increased. So this is the case. I do hope that you've got the concept. If you did do like the video, probably in the next videos we will talk about the soil, the types of solid, the crystalline and the amorphous. Meet you guys in the next video. Till that, goodbye.